Hi everybody. In this video, we're going to talk about solving equations. Now, our goal whenever we solve equations is to find the value of x that balances both sides, that is, makes both sides equal. And of course, the variable or the unknown, it doesn't have to be x in every equation. It could be a c or a d or a q or whatever, but it's very common to see equations written with x's in them. So that's what I did in this video. So let's take a look at our first equation. We have 2x plus 1 is equal to 9. And here we have a representation of that equation with a scale. So when I say 2x over here, we can think of that as two x boxes, what I call x boxes. You probably think of an x box as something different, but this is what I call an x box. So we have on the left side of the equation, we have 2x plus 1. So we have two x boxes plus one stone. Let's say that these are all stones over here. And then on the other side of the equation, we have 9 stones. So you can count them. It might be a little bit hard to see, but 1, 2, 3, 4, 5, 6, 7, 8, 9. So on the left side, we have two x boxes and one stone. That's the 2x plus 1. And on the right side, we have 9 stones. And what we're trying to figure out is how much each of these x boxes weighs. So we assume that both x boxes weigh the same amount, but we don't know how many stones is equal to one x box. Okay, so does one x box have the weight of 3 stones, or does one x box have the weight of 7.5 stones? We don't know. We're trying to figure out the weight of each x box in stones. Now, one way that we could start doing that is to take this stone away. Okay, because right now I know that 2 x boxes plus 1 stone is equal to 9 stones, but I don't want to know what 2 x boxes plus 1 stone is equal to. I want to know just what 1 x box is equal to. So I can start out by just taking away one of these stones. And before I scroll down, think about what would happen if I did that. Right now, I have a scale where both sides are equal to each other. So each side has the same weight, exactly the same weight, so that everything is in balance now. That's why this line over here is parallel to the ground, even though there's no ground in this picture, because both sides are balancing each other out. If I were to take one of these stones away from this side, what would happen to the scale? Well, you probably guessed it. It would tip to this side. Okay, so if I scroll down here, you can see that what I wrote in the equation is I tried to take one away from the left side. And by the way, when I say left and right, I'm talking about the equal sign here. What's to the left of the equal sign and what's to the right of the equal sign. So this is the left side of the equation, and this is the right side of the equation. And you can see when I tried taking that one stone away from the left side, but I didn't do anything to the right side, so the right side still has 9 stones on it. The right side becomes heavier, so it tips more. Okay, so I can see here that if I take one away and I get just 2x on the left side, and still I have 9 stones on the right side, 2x is not equal to 9. They're not balancing each other out. So I have to be a little bit more clever. I want to get the x's by themselves. I want to have just one x by itself. I can take things away, but whatever I do to one side, I have to do the same thing to the other side in order to keep everything balanced. And that's the next little lesson that I wrote here. Whenever we change the weight of one side, either by adding, subtracting, multiplying, or dividing, we need to change the weight of the other side by the same amount. And just a little note here, what I said a few seconds ago, the equal sign is what separates the two sides of an equation. So if I took one away from the left side, I need to take one away from the right side also. And you can see that's the picture that I drew here. So again, we're starting out with 2x plus 1 is equal to 9. That's this picture. If I take one away from the left side, so I take this stone away from the left side, then in order to keep everything balanced, I would have to take one stone away from the right side also. And you can see here, even though it kind of looks the same if you just glance at it for a second, there are actually, if you count them, there are only 8 stones here now. Let me make sure I did that right. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, just 8 stones over here. So now I know that 2 Xboxes balance out exactly 8 stones, not 9. Okay, so I'm getting closer. What I want to do is really just get 1 Xbox by itself to weigh it. Okay, so the next thing that we could do, since we have 2 Xboxes over here, the next thing that we could do is divide by 2. So we're going to cut the weight of this side in half. When you divide by 2, you're cutting the weight in half. And we're also going to do the same thing on the other side. We're going to cut that weight in half. Okay, so now if we did that, if we started out with 2x equals 8 over here, if we divide both sides by 2, so we're cutting this side in half and cutting this side in half, then on the left side we only have 1x, so that's what I wrote over here. If you don't see a coefficient in front of x or y or whatever letter you're using, then it means that there's just one of it, but we normally don't write the 1. So I have 1x on the left side is exactly balancing out 4 stones on the right side. And they must be balancing out because they started out the same over here. Okay, so the weight over here was exactly the same as the weight over here. And then if I cut this weight in half and I cut this weight in half also, both sides should still have the same weight. Not the same weight that they had before, but still the same weight as each other on the left and on the right. Okay, so I just figured out that 1 Xbox must be equal to 4 stones. All right, so again, whenever we change the weight of one side by adding, subtracting, multiplying, or dividing, we need to change the weight of the other side by the same amount. All right? Next thing, what's the next thing that I want to say? Here it is. We need to check our answer. So check your answer by plugging it back into the original equation. So I just went through everything with you very meticulously. So I'm pretty sure that my answer is right. But what if you're not sure if you got the right answer? Well, you can check it by taking what you got for X or D or Q or whatever and plugging it back into the original equation. So what we're saying here is that each of these Xboxes has a weight of 4 stones. Each Xbox exactly balances out 4 stones. Well, if I take that information and go back into the original equation that I had, does it make sense that each Xbox weighs exactly 4 stones? So I'll just draw it onto the picture and then we'll do it in the equation itself. If this Xbox weighs 4 stones and this Xbox also weighs 4 stones, we have 4 plus 4 is 8 plus 1 is 9, which is exactly what we have on the other side also, right? So each Xbox must have been equal to 4 stones the entire time. Otherwise, this wouldn't have been balanced in the first place. And obviously, you're not going to draw a picture every time you do this. So what we could do here is we can just plug 4 in everywhere we see an X, which is just, this is the only X that we see in this particular equation. So we have 2 times 4 plus 1 equals 9. So 2 times 4 is 8. So I have 8 plus 1 equals 9. And 8 plus 1 is 9. So I have 9 equals 9. So it all makes sense. So the left side is equal to 9 if X is equal to 4. And the right side was also equal to 9. Okay, so the next thing that I want to talk about here is that if you're multiplying or dividing, you have to do it to everything. So let's take a look at the same example that we just did. So let's start out with 2x plus 1 is equal to 9. So that's the picture for it over here, same one that we saw before. Now, we don't have to begin by subtracting 1 from both sides. I personally think that it's usually easier to do addition or subtraction before you do multiplication or division, but we could if we had wanted to. Since this is 2x here, this means 2 times x, and the inverse of multiplication is division, we could have started off by dividing both sides by 2. Now, this is how a lot of students do that, and they make mistakes when they do that naively, like I'm going to do over here. So they'll divide this side by 2 and divide this side by 2. So 2x divided by 2 would just be x, and 9 divided by 2 would be 4.5. And it's a common mistake to keep that 1 here just the way it is. Now let's take a look at what's going on in the picture to really understand why that's incorrect. Because you might be looking at that and thinking, well, that seems perfectly fine. What's wrong with that? It actually is no good, and here's why. Actually, I'm going to start looking at the right side first. So take a look at the right side. We had 9 stones, and then we divided by 2, which means we cut the weight in half. Okay, so we took 9 stones and we cut the weight in half. So now instead of having 9, we have only 4.5, 4.5. So 1, 2, 3, 4, and there's a half. So far, so good. But what about the other side? Remember, both sides started out exactly the same weight. Everything was in balance. So if we cut the weight of the right side in half, then we better make sure that we cut the weight of the left side in half also. The key point here is that some of the weight is in this stone. So if I only cut the weight of these 2 x's in half, then I'm really not cutting the weight of this entire side in half, am I? If the stone had not been there in the first place, then it would have been fine. So if we had just had 2 x's in the first place, then by taking 1 away, we cut the weight in half. But since we have the 2 x's plus the 1 stone, taking just the 1 x box away doesn't exactly have the amount of weight on that side. Okay, so what should we have done there? When we divided this side by 2, and this side also, we should have divided everything in half. We should have cut the weight of everything that we saw in half. So again, this side was cut in half from 9 to 4.5. If I have 2 x boxes plus 1 stone and I want to cut the weight of this side in half, I need to cut the weight of the 2 x boxes in half, and I also need to cut the weight of the 1 stone in half. All right? So the 2x divided by 2 is equal to x, and the 1 divided by 2 is equal to a half. So now I have x plus a half is exactly balancing 4.5. And then the last thing that I could do to solve that equation would be to subtract a half from both sides. So sometimes I like to draw a line through here and say that these are canceling. Really what I'm doing is I had half of a stone, and now I'm just taking it away, so there's nothing left there. So now I have x is equal to, and then I, of course, need to take half a stone away from this side also. So again, you can see that we get the same answer that we got before, which is that one of these x boxes should be equal to the weight of 4. Now, even though I just gave you a division example, it's important to understand that the same principle applies for multiplication. So what if I had, instead of cutting the weight in half, what if I had doubled the weight of this side? So instead of having 9 stones, what if I put another 9 stones here? Let's count those quickly. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I just doubled the weight of this side. Then in order to keep everything balanced, I would have to double the weight of this side also. And that doesn't just mean the x's, that means this stone over here as well. So if this balanced this over here, then I would need another one of these, let's just call it a package of x boxes and stones. I would need another package of 2 x boxes and 1 stone to balance out this additional weight that I just put over here. So it works for multiplication and division, right? It's a very common mistake. If I start out again with my equation 2x plus 1 equals 9, And let's just say there's really no reason to multiply by 2 here, but let's just say that I wanted to do that anyway. If I multiplied this side by 2, so I get 18 on this side, just like I have over here, then I would need to multiply every single thing on this side also by 2. If I just multiplied the x's by 2, so 2x times 2 is 4x, if I just multiplied the x's by 2 and I didn't multiply this by 2, so I get 4x plus 1, then that would be like if I had not drawn this stone in here, which wouldn't be good, right? Because then everything would start tilting to the right side. So that extra stone has to be there. So I can't just multiply this by 2. I would need to multiply this by 2 also. So 1 times 2 is 2. All right, so I have 2 stones instead of just the 1. Okay, now really in this equation, there would be no reason for me to want to multiply both sides by 2. That doesn't get me any closer to getting just 1x by itself. But it still does, it's still fine what I did. It just doesn't help me get the x by itself. But the idea is still valid. If I double this side, I have to double everything on this side to keep both sides balanced. Stones. Right, now let's move on. Next thing we'll talk about is removing the variable from one side. So if x is on both sides of the equal sign, you'll need to remove it from one side. Here, I only had an x on the left side of the equation. But what if I have an x on the left side and also an x on the right side? So let's take a look at the next example. All right, over here. So we'll start out with 2x plus 3 is equal to 5x. So these x boxes don't necessarily weigh 4 stones anymore. This is a different problem now. And I know that 2 of these x boxes plus 3 stones is equal to the weight of 5 x boxes. And I have to figure out, in order for that to be true, what must the weight of each of the x boxes be? Okay, so what I can do is since I have x on both sides, I want to remove it from one side. Remember, we want to end up with just a single x box on one side of the equation, because then we can just look at the other side of the equation and see very easily how many stones are balancing that one x box. So I don't want to have x's on both sides. I need to remove it from one side. Now, it would be correct actually to subtract 5x from both sides, and then we would get a negative number of x's on this side, which is okay. But just to keep things simple, I subtracted the smaller value, so I still have a positive number. So I subtracted 2 x's from both sides. So again, this is what it started out as. If we take away 2 x's over here and we take away 2 x's over here, then we end up with 3 stones and 3 x's. Okay, so that's what we see here. We can cancel these out, and then we're left with 3 on the left side and 3 x's on the right side. Okay, now it might be pretty obvious now how many stones is equal to 1 x box now, but let's just continue. So now we have the equation 3 is equal to 3x. So the next thing that we'll do, oops, okay, so I guess I didn't draw the picture for it, but it's easy enough to do over here. So the next thing that we want to do is, since we have 3 multiplied with x here, we will divide both sides. And very often, in the last example, I used the division symbol, the standard division symbol, the 2 dots, and then the bar in the middle. But now I'll just use a fraction bar to represent division. So if I divide this side by 3, what does that mean? That means I only have a third as much weight as I used to have on the right side. So if I had 3 x's before, Now I only have a third as much. So now I only have 1x over here. Okay, and I need to do the same thing on the other side. So I need to divide the other side by 3 also. I'm dividing by 3 here, not because this is 3, but because I divided by 3 over here. And whatever I do to one side, I have to do the exact same thing to the other side in order to keep everything balanced. So I'll divide by 3 on this side as well. So 3 divided by 3 is 1. And you can see from the picture that makes sense. If I have a weight of 3 stones and I want to only be left with a third of what I had before, then that means I'll only have 1 stone now. So now, if I want to just draw it a little bit neater, well, I don't know, based on my handwriting, I don't know if it's actually going to come out neater, but now I have just 1 X box on the right balancing out exactly 1 stone. So obviously each X box had the weight of 1 stone all along. And again, we can go back to the original equation, which we had right over here. If this box had a weight of 1, and in fact, all of the X boxes had a weight of 1 stone, that is. So stone is going to be our unit of measurement here. So we have 1 plus 1 is 2, 3, 4, 5. And then on the left, we also have 1, 2, 3, 4, 5. So it makes sense. So we just checked our answer, right? We could have checked it also back in the original equation. If I plug this back in here, then I get 2 times 1 plus 3 is equal to 5, and also over here, because I see 2 x's now, it's equal to 5 times 1. Every x is equal to 1. Then I get 2 times 1 is 2, plus 3 is equal to 5 times 1 is 5, and 2 plus 3 is 5. So I get 5 equals 5, which is good. All right. And moving right along, I think I have one more example. Okay, so what if we end up with nothing on one side? If you end up with nothing on one side, put a 0 in. So let me show you what I mean by that. You saw this earlier when I accidentally scrolled down too far. Okay, so what if I had started out with the equation 7x plus 6 equals 4? Here's the visual representation of that. And I have x boxes on both sides. I only want 1 x box on one side. So I'm going to have to remove some x boxes from one side. What if I subtract 4x from both sides? So I take 4 x boxes away from here, and I take 4 x boxes away from here. Then on the left side, I'm left with 3 x boxes and 6 stones. And on the right side, if I had 4 x boxes to begin with, and I take 4 x boxes away, then I have nothing on the right side. I know that this doesn't look like it makes sense right now, but just hold your disbelief for a moment, because the point that I'm trying to make right now is not that this doesn't make sense. Actually, it does make sense. You'll see why in a second. But the point that I'm trying to make here is that over here on the right side, we ended up with nothing. And a lot of students, when they're solving equations, if they end up with nothing, they'll forget to keep the equal sign here, and they'll just write this, and then they won't know what to do after this. Okay? So what we need to do if we end up with nothing here is we need to write the equal sign again, and then usually we would just cancel the 4 x's out and not bother to put anything. But if that was the only thing on this side, there has to be something written there. So what we're going to write here is 0. Okay, so we have 3x plus 6 is equal to 0. And here is the representation of that. I know it doesn't make a whole lot of sense looking at that. How could 3 x boxes and 6 stones be exactly balancing out the weight of nothing? Well, we could solve this equation. I'm just going to solve it in the normal way now. So this is plus the inverse of addition is subtraction. So I'll subtract 6 from both sides. So I have 3x is equal to 0 minus 6 would be negative 6. And then to get rid of the 3 here, I'll divide by 3. So now I have x is equal to negative 6 divided by positive 3 would be negative 2. So that means that each x box has the weight of -2 stones. So what does it mean to have a weight of -2 stones? Imagine that each Xbox was filled with helium like a balloon. And here is, so imagine you're holding a balloon. So one Xbox can lift exactly 2 stones. So the force of one Xbox moving up counteracts the weight of 2 stones with their force pointed down, right? So you can think of these as balloons, which are actually moving up if it's a negative number. So you should probably also imagine that the balloons are connected to each other, and the balloon on the bottom is tied to the scale over here. So when the balloons move up, they try to pull the scale up with it. We have 3 balloons moving up, and each balloon counteracts the weight of 2 Xboxes of 2 stones moving down. So this one counteracts the weight of these 2, and this one counteracts the weight of these 2, and this one counteracts the weight of these 2. So all together on the left side, we have a weight of nothing, which is balancing out the nothing that we have on the right side also. So I don't need you to worry too much about that, of thinking of a negative Xbox as a balloon going up. Don't worry so much about that. The only point that I really wanted to make there was that if you cancel this out and then you have nothing left on the side, you need to put something there. You need to write something in there. So don't forget to put the equal sign, copy the equal sign down just like you normally do, and put a 0 there. And then you can continue solving the equation from there. Okay? All right. Have a great day.